Welcome to Analyst Crossfire, an ISC 15 panel featuring expert voices from the international supercomputing community giving their reactions to some of the top HPC trends as discussed at this year's conference. I'm Addison Snell with Intersect 360 Research, and I'm the moderator for this panel. And joining me, as usual, the ISC organizers and I have selected 2 members of the HPC technology vendor community and 2 members of the HPC user community, and these 4 have volunteered to play the analyst by sharing their personal opinions on current and future supercomputing trends. From the HPC user community, we have 2 well-recognized HPC experts representing perhaps different perspectives of the market. First, on the commercial side, Ryan Quick is Principal Architect of Advanced Technologies at PayPal. Hello, Ryan. And second, the always interesting CEO of the A-Star Computational Resource Center in Singapore, Dr. Mark Mihalowicz. Mark, thanks for joining us. Representing the vendor community, I've tapped 2 HPC executives who each already navigated hot seat questions on the ISC Vendor Showdown on Monday. Senior Manager at NEC Deutschland, Rudy Fischer. Welcome, Rudy. And finally, the CEO of RSC Technologies in Russia, Alexander Moskovsky. Alexander, thanks for being here. Panelists, thank you all for joining me for ISC Analyst Crossfire. The clock is running and we're going to get started. Issue number 1 is called Chinese Entities. Earlier this year, the U.S. government placed major Chinese supercomputing sites, including NUDT, the site of the Tianhe system, on the so-called entity list for non-export of U.S. technologies over concerns the systems were being used for nuclear research. What do you think of this decision and this development, Rudy?
Idealistically, I prefer...
We got to get the mics on.
Idealistically, I prefer cooperation over confrontation. Realistically, I cannot really believe that in the long run China would have a problem with this. They have this Godson and Dragon core architecture. They can do this with a little delay anyway. And rationally or strategically, I think if you cooperate, then you have some insight into what your partner is doing and you have perhaps some control. So I think that would be the way to go.
Cooperation between whom? Who should be cooperating, the U.S. or the Chinese?
For instance, Raj Azra from Intel in 2012 was offering the Chinese architects for the Godson that they should rather cooperate than continue on their own. For instance, that would be a thing.
All right, Alexander, what do you think?
I would support Rudy in forms of cooperation is better than confrontation. First, and then it's really tough for me to decide because it's have no business with Chinese and U.S. government actions are beyond my control. I would
Being a Russian vendor in particular, I would say U.S. government actions are beyond your control. Does that color your opinion at all?
No. So I would say that these actions will just boost the government investment in the CPU technology, not only Chinese, but around the world too.
All right, so I'm hearing 2 opinions from the vendor side that are vaguely against this, but maybe a little reserved in saying that this is terrible. All right, get to the user side. Mark, I'm doing you last on purpose. Ryan, get in there.
All right, so, I think that, to be honest, it's not really going to change much of anything. I'm pretty pragmatic, and what you've talked about is, and the end result here is you've lost a resource, and so you find another one. That's what's going to happen. I think,
Sorry, who's lost? The Chinese supercomputing sites in particular have lost a resource, so they find another resource?
Yeah, the Chinese supercomputing sites have lost a resource, they'll get another one. Intel has lost a channel that won't hurt them. They'll be all right.
All right, well, it's not specific to Intel, right? There's no U.S. technology that's going to be exported to any of these sites. So when you're saying they'll find another resource, you're thinking...
At the end of the day, the grand total, even if you add it all up together and multiplied it by 10, is still not going to be enough to make a real difference. So I think at the end of the day, it doesn't really change much of anything. Chinese will find a way, and so will the vendors.
All right, so Mark, you're operating a major international academic supercomputing site. In some sense, these are your peers. What do you think of this development?
Well, first of all, that's not a precedent. Actually, Russia has suffered a similar thing with T-Systems, and actually most probably it helped the Russian supercomputing
I
system.
implied that in my follow-up question, but wasn't so aggressive as to say right away. I was thinking I might come back to it, but you brought it up, so go ahead, keep going.
So it happened before with others, it happens now. But in terms of China is a huge market. First of all, they already have stable system with Intel, and it will serve them for a few years. It's already been on top 500 for quite a while. It will remain maybe for another year or so, half a year. But they have their own architecture, not so much own. They have IP stack for every other single architecture. They have Shenwei, they have access to ARM, they have MIPS processor with Longshan, they have and they have Spark. And even yesterday at HPC, a meeting organized by INSPER, one of the speakers from Guangzhou mentioned that that's a backup position. They can use their own Spark.
Well, certainly this could accelerate the domestic Chinese technologies within the company, the indigenous Chinese technologies. You didn't list open power on that list. They have license for open power or not?
They have fabs that will be building processors using open power. Plus, in Hong Kong, they also have a company called iCube with their own native architecture.
All right, I stayed on you for a while there because I knew you had a comprehensive answer to this. I'm going to come back up the line. Ryan, you're coming from the commercial side. Marek's going in big on this. You said, it doesn't matter, I don't care. Did you evolve your opinion there or not?
No, not at all. I still don't think it matters. I mean,
all right, then forget it. I'm going to go back on the vendor side. All right, what should happen next year? What do you think will happen next year? Rudy?
I'd love to know. Politicians are involved, you never know. But at least if it would come to this, then they will find their way for sure. I mean, it's 1 billion people and at least 1 million brilliant minds. They will find their way, whatever it is, and they have some technology already now. So why should this be a problem?
Why should it be? Well, that's a good point. Is why should it be a problem, Alexander?
I revert Marek's remark on Russia example. So in Russia, we enjoy a healthy competition from our friends and T platforms. So I think so in China, the issue will be resolved somehow.
Personally, I was delighted to see T platforms coming back from all of that. You know, out of all of it, one of the things that almost mystified me in the whole deal was the idea that we're shocked at the idea that there could be nuclear research going on these computers. That just, I would have always assumed there could have been nuclear research going on those. Why wouldn't there be, right? I just didn't get that being a surprise to anybody. Anyway, clock moving on. Issue number 2 is the future of HPC ISVs. In our HPC surveys, we're tracking a trend overall across HPC more away from commercial licensed ISV applications toward in-house and especially open source applications. OpenFOAM is the fastest growing individual application we're tracking anyway. How can or should ISVs respond, Ryan?
So, you know, I'm a software company, but we use mostly open source and we produce open source. So, you know, I think that the days of constraining resources to a license are over, and people just got to get used to that. I'm not necessarily saying that everything's got to go open source. I think it's a good way to get pieces developed that are outside the expertise of the core group, and that, for that it's a good thing. But you know, for me, one of the biggest problems that we've had coming into HPC in the first place in dealing with licenses was I have a rule that says I can't have a single point of failure result in a single failure, like an ultimate failure. And for me to be in a conversation where I had to explain that missing a license prevented me from being able to service a customer would be a non-starter. So in some ways that takes licensing completely off the table. We wouldn't do it.
Well, you kind of don't care what's going to happen to the ISVs because you're in favor of open source anyway.
Well, I mean, but we are an ISV, right? You know, we have 3 million lines of software that we defend.
That's a fair point. I wasn't really considering that in my perspective. I'm thinking of some of the more traditional HPC ISVs in this space. Mark, what do you think?
Well, that's excellent. That's an excellent thing that we're talking about it, because for many years I was trying to get to discussion with ISVs to change pricing model. I think the worst problem is that there's no incentive for, very often the technical software operates very well on the workstation type of resources, and the market is very different. And then the model for pricing translated into HPC is killing HPC and doesn't have incentive to ISV to scale up.
I want to push back on you a little bit on that, though, because when you say you want the ISV to change their pricing model, is that code for I don't want to pay as much for how much I want?
No, I'm prepared to pay for very good codes, legacy things, and things. But the price cannot scale like Moore's law exponentially with the number of cores. So, for example, the model of pricing per core is insane. And so for several years now, I've been trying to negotiate licenses nationwide. So part of our recent tender includes options for vendors bringing licenses that will be open to 100,000 students in the whole of the country. Of course, separating academic from commercial.
Right, separate academic because you should get it for free anyway. Alexander.
That's other part of the question for me. I am neither ISV nor hard user of licensed software. I just may guess that what we see from our customers and science and education that the entry price for them may be quite high and for prohibitive. And maybe some more flexible models, especially for science and education, may be the answer.
So I'm hearing twice now change the models. Do you think there's a pricing model that allows the ISV to operate profitably on an ongoing basis? Stick with Alexander.
Yes, there. Of course, I'm not the ISV, so I'm just guessing.
So you guessed that there is. Rudy, you were nodding emphatically there for a little while. Get in there.
In a way, yes. I mean, what we see there, and you mentioned open forum, we see this really showing up a lot in the German industry. What we're seeing there is this basically what is open source all about. So why should ISVs not have to cope with this, which is just a different business model? And they have their services, they could customize for certain customers, they could optimize for certain customers, they could develop things. So I think they have to go this way. And yes, I think their past pricing models partially were prohibitive, so it's their fault, they have to adapt.
Well, it does seem they have to adapt. I'll add one other wrinkle into this. I was recently at a U.S. federal big data summit, and I was asking about software, heard a big preference for open source software with the implication that it should be free software and that the government, with apologies, is a U.S. government, but I think it extends, that the government would even invest in the creation of this ISV software. So my follow-up idea is, does it actually make sense for the government to be spending public money for the creation of free software that competes with commercial software that already exists, Rudy?
I didn't have this idea until now, but somehow I like it because it's about building up expertise. It's about having a lot of students becoming experts in something. So I like this idea, government-sponsored.
Alexander, do you like that idea, government sponsors open source?
We saw many governments in Europe and in Russia to spend money in such a way.
Do the end users like that idea? Should the government be spending public money for creation of free software?
I don't think we care. I mean,
You don't care?
More software.
Mark, do you care? Ryan doesn't care about
Actually,
me.
if I said no, I would be a hypocrite because I actually will be spending government money to do precisely that.
I'm in the
I have
minority.
some-
I don't think that's an appropriate use of public funds for the government to compete with existing industry, but I bow to the opinions of the actual users and vendors in this market. Clock moved on. Issue number 3, no more, get it, no more scalability. If we assume that Moore's law is coming to an end or at least slowing down, then what will drive scalability and performance going forward, Alexander?
That is my question, yeah.
No, it's my question. You get to answer it. When we go to a strategy session, then I have to answer it for you. This panel, you answer it for me.
Okay, I understand. So we see, for example, even now, the specialization of the architectures like the Xeon Phi architecture from Intel that we use heavily. And the what is happening with the ecosystem is that it is necessary to innovate not only in the architecture but simultaneously in the software to implement the efficient, effective software on the new architecture. So I think that will be more and more the case for the future developments.
So Moore's law notwithstanding, we're still looking at architectural advancements that are going to keep driving scalability. Rudy, what do you think?
I'm basically in the same line. I really believe that we are now at a point in time where architectures are debated heavily. Perhaps new things are showing up. Perhaps some old ideas like vectors would come up again much more. I'm not so optimistic that that will be something like an order of magnitude enhancement in the future. It will very much go down again to software developments that we had in the last 20 years, which is a burden for the user. So, but again, I would like to rephrase. 1,000 times a happy scientist with a petaflop sustained is more important for me than an exaflops in HPL, and therefore, I think the petaflops for the scientists, this is still a goal that we could go for.
Alexander, you almost spit out blood when you bit your tongue there for a second. What were you going to say?
Yes, and not only the innovation in the software, but in the system design as well. I would not even stick with the performance because what may be more important, the power performance.
I'm going to get back on this software, but I got to get to the other end of the table first. On the end user side, where is increased performance and scalability going to come from, Marek?
Yeah, there are new opportunities for specialized architectures. This morning there was a session on brain modeling. So you see implementation of certain algorithm in silicon, and you have computers like Grape MD, Anton won the prizes last year, and of course special hardware for brain. And so you can actually hardwire certain problems if it's sufficiently important. That will provide extremely efficient architecture. Another line will be, of course, integrating interconnects with processors. Intel is moving that direction, and of course also exploiting topologies of interconnects.
This is my favorite kind of answer because it was specific. Now, Ryan, I'll get you in there, and if you say you don't care on this one, I'm going to.
This one I care.
You would better care about this one.
No, I care. All right. So, but I do have a different answer. I think.
Good.
I think the two things that are going to drive the most are power, and by that I mean driving power down, not more of it. I think that's going to force us to make some hard decisions and to look places we haven't looked before.
When you say driving power down, looking somewhere you haven't looked before, are you looking at something like ARM?
Yeah, I'm thinking ARM. In fact, my next thing is. I'll get to it.
Sorry, I interrupted you.
No, it's cool. The other thing I think is that real-time data analytics is going to surpass what we're calling big or huge data quickly. And the reason there is
the fast data angle.
Yeah, we can't keep this ball of data forever, right? We're going to have to figure out how to get intelligence out of it faster than it comes to us, and it's coming to us faster and faster. So the only way to be able to solve that is going to be real-time, and you're going to do that in small stuff.
All right, well, now I got to get back down here, though, because I have to follow up on the software comment, because this is consistent with a study that we did with the United States Council on Competitiveness, looking at next generations of performance and leadership for industry, that it was all coming down to software, especially against this backdrop of a return to specialization, diversity of architecture, and pursuant to the previous question, what needs to happen for software innovation now to keep pace, if that's where the hardware innovation is coming from, Rudy?
I would love to know. The only thing I see, and for instance, we are now discussing to drop cache coherency. That has a huge impact on software. So I think that software is becoming even increasingly important without additional developments. Honestly, what is going to happen with software, I have to admit, I don't know. There are certainly a lot of things that one can optimize, and quite honestly, there are also other things which kick in, like I/O and such, which are limiting factors. So there is still some space to do this, and this is also software. How to do structure I/O. There are a few things that you can do, perhaps for another factor of 2, 3, perhaps 5, but I don't see the order of magnitude.
Alexander, you got an idea on software for us?
Software, that's important, I think.
Yeah, Marek, you got a specific idea on software like you did with the others?
Well, there will be certain changes driven by architecture, and for example, this unified memory image offered by new architecture from NVIDIA Open Power may ease pain of
That's at least an
partition.
idea we can explore. I got to tell you, when you said I don't know, Rudy, one of my favorite terms I've ever heard in my entire industry, the one that make me laugh, is when people talk about MPI plus X. And it's not that it's a bad idea, it's just a funny name that implies, well, what we're going to do is we're going to take what we have now, which is MPI, we're going to add something, I don't know, let's call it X, and that's going to save us. It's just a funny name. We're into the speed round now, if you thought you had too much time before. Virtual question. We've been talking about this, one topic I've been surprised I've talked about so much this week is virtualization, software-defined, hyper-converged, containers. What's the role of virtualization now in HPC, Marek? It's been a big topic this week.
Excellent. I'm very happy to answer this question. I have few experts with me. We work on something called InfiniCloud. We have realized the HPC instances for a very large number of servers with underlying fabric being InfiniBand. So this is the real...
You're saying yes, virtualization.
Yes.
We're going to virtualize it all, Ryan. I thought that was the answer was going to come from Ryan.
I thought everyone was virtualized when I first started.
Yes, we're
coming
going to
to these, so
virtualize everything in
it surprised
HPC.
me that we weren't. So, I'll just say it flat out. Hardware has outpaced software.
Alexander,
Virtualization
what are we going to
replacement.
do here? Virtualize?
In our experience, we don't see much demand from our customers for virtualization. However,
That's more the answer I would have expected. Go ahead.
But what are these blooming technologies in virtualization and software impact very much software management.
Yeah.
And all the management solutions we have inbreed the technology from the all virtualization solutions.
Rudy?
I consider the virtualization and all these things another way of the provision. We see this in our customers, and Joseph yesterday said it's about 30%, I think. We see this, but we don't see it as the high end. We see it as something for a broad user community which are doing many single core jobs currently, which are doing moderately.
We've tracked virtualization in HPC for a long time as well, but it's always been low. Virtualization and HPC have been allergic to each other because of the overhead. I think the new advancement here is containers, which is bringing the overhead down, so maybe we're going to start seeing it more. Now, we're just talking about diversity in hardware architectures on the server side, but there's a lot of diversity in software, or storage, excuse me, here also. Does this mean that users have to think a lot more when they specify their storage in an RFP, Rudy? They can't just say, I need 500 terabytes of RAID, right? What do they need to do?
No, and we understand, and we have this very often in RFPs, that it's highly difficult to really profile your I/O. And we are trying to develop in cooperative ways with our customers specific storage concepts, but this is now just starting. We realize that I/O is an issue. Seymour Cray said supercomputers are memory with CPUs attached. I think now we have storage systems with servers attached. And that is the problem currently, and users are not so aware, quite honestly.
Alexander, what do you need to do?
I think we need more profound benchmark set for the from the user side.
That's an interesting point. We do so much work on benchmarking, all kinds of things on
I
the
think
compute side. We want to
what we
benchmark
have
the
now is
storage
not,
more. Ryan, you shrugged. You don't care. Ryan
I do.
doesn't care.
I think it comes down to two things, right? I/O slows as durability increases, so you got to design for that. And if you don't, you're making a mistake. And I/O changes over time, and if you don't design for that, you're making a mistake. It's just that simple. You have to do it.
Marek, how are you specifying storage?
Well, actually, I have, because on 15th of June, we closed the tender for petascale system in Singapore. I spent a lot of time thinking how to, precisely how to spec it out. We spec'd it 10 to 1, 10 petabytes of storage for 1 petaflop of system with extremely high I/O. So we spent a lot of time to benchmark the proposal. So that was a huge item on our RPF.
Last speed round question. I've been looking forward to this one. This is the ultimate fast answer. This is about a one-horse race where somebody's currently way out in front and there's a challenger who's currently 10 lengths behind in the race. I want you to tell me where they are in 3 years. Race number 1, Open Power is currently 10 lengths behind Intel x86. Mark, where are they in 3 years? Where's Open Power? Are they catching up? Are they ahead?
Yes, they will catch up.
How much? They're 10 lengths behind now. How close do they get in 3 years?
Not alone, but with GPUs, they will be on par.
Ryan, how close?
I don't think there's going to be any change, but I think that there's a guy wearing an ARM shirt keeping up with them that's wondering why he's not invited to the track.
All right, I considered that, so you're saying ARM's catching up, not Open Power. Alexander.
open power catching up, but not on par with Intel.
Rudy?
I agree to that, and I'm very happy that there is at least a valid competition.
Yeah, I think they're going to start closing the gap, but hard to catch all the way up. Leader is GPU accelerators, challenge is FPGA accelerators. I'll go the other way. How much do they catch up?
Thank you very much, because I like it. Wrong question. The FPGAs for me will remain a niche product, but there will be a proposition from NEC, the next generation vector.
Alexander?
That might be catching up in 3 years because what all we discussed about new low-end architectures.
Starting to catch up. Ryan?
I think they're getting closer, but they're spending all their time trying to figure out how to become more general purpose.
They wind up 9 lengths behind, he says. Go ahead, Mark.
I don't think they will close gap ever. These are prototype systems.
I think they close the gap in hyperscale, but not really in traditional HPC. OmniPath is the challenger against Mellanox. Ryan, how close do they get?
I think they're neck and neck.
They'll get neck and neck. Mark?
They will close gap, but no.
They'll close the gap. OmniPath, they catch up to Mellanox. Alexander?
I don't agree there are only 10 lamps. Maybe the dust on the horizon. But Intel will catch up.
Intel will catch up all the way. Rudy?
Quite honestly, I thought that Intel would become the leader, but fortunately, Mellanox will not disappear.
Okay, so you think they'll overtake, but Mellanox still in the race. I got one more I'm going to get here, even though the clock moved on. The challenger is U.S. in exascale. The leader is outside the U.S. in exascale. Is the U.S. going to start catching up in the next 3 years, Alexander?
Yes.
Yeah, they will. They're going to accelerate, Rudy?
I believe so. That's a matter of national pride also.
They'll accelerate from where they are now? What do you think, Ryan?
Yeah, I'm with them. I think they'll.
You think they'll start speeding up? Marek?
Well, they are speeding all the time, but they have very clever ideas, very modern, and in terms of solutions, they are very creative.
I think the announcements around CEA and exascale, and looking at 2020, were one of the biggest news stories that flew under the radar this week. All right, we're going to close with our traditional end of Crossfire category, one up, one down. I want each of you to tell me one thing you were impressed with this week, and maybe one other thing in the other direction where you might have expected something more. Rudy, I'll start on this end of the table.
Yes, my up, that is that there was the business was basically flat in 2014, but then I learned that it was also only for the top 10, and below that the market is growing, which means that there are more people who will have the chance to get something, to get access to the fast system.
So the volume part of the market
The volume
growing,
part of the market
you're
is still
happy with.
growing. And
We had the whole market at a small growth rate last
Yeah,
year,
small.
2-point-something%. Go ahead, Alexander. Oh, sorry, I didn't get your
On the down first, okay. Yeah, high performance data analytics. I saw this in Earl Joseph's presentation, and I saw that the first topics were that it's fraud detection, it's marketing, and business intelligence. And I was a little bit disappointed because I thought by that point in time we would already have some exciting science coming out of it, and this seems to be not the primary goal currently of HPE. The high performance data analytics.
I can't comment on IDC's methodology on that. I'm sure
I'm
it looks
sorry for
great.
that.
Alexander, no, that's fine. Go ahead, Alexander.
Intel
One up,
IPCC,
one
Intel IPCC community that dealing with the new software and the software adaptation for the new architecture. And one down, I think in top 500 results we have seen not so many new systems as previous years.
Not as many new systems previous years. You'd like to see that get going. I think it probably will start getting going. You'll start to see some race going here. Ryan?
So up, I'm very glad to see working silicon and automata.
That's a nice specific one. I like that.
Yeah,
An automata processor. Nice
Yeah,
call.
Very, very nice to see that. Down, though, I'm still not seeing a bridge between HPC and industry as much as I'd like. Had DDN reporting the other day that they are now seeing more storage being consumed by the industry side of their portfolio, but they're not here. And on the flip side, I still.
Oh, you mean industry participation in
Yeah.
the show, not so
Yeah,
much.
and I still don't see, things that industry has solved making its way back into HPC, like heavy messaging for things
Better
outside
link with
of-
industry. I could go with that. Marek, one up, one down.
Of course, Automata is my favorite. Actually, we'll be setting out of
Two
Automata
for Automata.
center in Singapore. but also the work in the Human Brain Project always impresses me hugely.
So you go 2 up, that's fair. I'll give you 2 ups, that's nice. I like the Human Brain Project, good call.
And in negative sense, we started with the Chinese, I will finish with Chinese. I'm very disappointed there is no better new science coming out from those huge machines. In case of K-computer, you see some very interesting Bayesian networks, graph theory, new work, but from Chinese we don't see some sort of breakthrough sihance.
All right, panelists, thank you. That concludes Analyst Crossfire. Audience, please join me again in thanking my panelists, Rudy Fisher, Alexander Moskovsky, Mark Mihalowicz, and Ryan Quick for bravely sharing their insights, as well as the excellent ISC events team for another successful ISC conference. I'm Addison Snell, Intersect 360 Research. I look forward to seeing all of you again next year. Thank you.